One of the greatest scientific missions of modern times has taken a giant leap forward today with the launch at lunchtime of the James Webb Space Telescope.
The James Webb Space Telescope wasn't just launched to take pretty pictures. It was built to change everything, and now it just did. For the first time in human history, we're not just inferring the existence of planets orbiting distant stars. We're actually seeing them clearly, directly, with details. And not some speculative computer-generated artist rendering. This is a real image, captured by the most powerful space observatory ever built, and the planet, a gas giant orbiting a star hundreds of light years away from Earth. It glows in infrared like a slowly turning ember, bands of color curling across its atmosphere, like a canvas painted by alien weather. But this isn't just about what it looks like, it's about what we can now do. Let's rewind for a second. For decades, exoplanets, the name we give to planets outside our solar system, were detected indirectly. We looked for subtle dips in starlight as they passed in front of their suns. We measured gravitational wobbles, we built models and guessed what they might be like. But we'd never seen one. Not like this. That all changed when the James Webb Space Telescope turned its coronagraph toward this gas giant. That's the instrument that literally blocks out the blinding light of a star to reveal what's orbiting nearby, like shading your eyes to see what's in a car's headlights. Only this headlight is 600 trillion miles away. What Webb captured is more than a photograph. It's a scientific milestone. For the first time, a human-built machine has pulled out a planet's thermal signature, its reflective glint, and its atmospheric fingerprints directly from the noise of the cosmos. And what those fingerprints reveal is something extraordinary. Inside this planet's atmosphere, Webb detected methane, water vapor, possibly even the hints of complex organic molecules. These aren't just chemical curiosities. They're the ingredients of chemistry as we understand it, the same chemistry that makes life as we know it even conceivable. Webb didn't just take a picture, it listened. Using its near-infrared instruments, it picked apart the scattered light streaming through the planet's atmosphere. And in that scattering light bent, bounced, absorbed it, found clouds, possibly storms, maybe even auroras at the poles, dancing across the gas layers like ghostly fireworks. The atmosphere's thermal signature shows temperature gradients, variations from pole to equator, and signs of atmospheric circulation. This is weather, not imagined, but observed. And the implications are massive. This is a turning point. Astronomy just shifted from inference to evidence, from guessing to seeing. Webb's observation provides a complete data set: heat distribution, light curve, variability, cloud opacity, and the presence of greenhouse gases. We're starting to determine things like pressure, axial tilt, even rotation speed. All of this from a planet you can't see with your own eyes. This gas giant glows with its own internal heat webs. Infrared eyes pick that up too, by analyzing its albedo, the reflectivity of its cloud tops. Scientists can now estimate how much sunlight this planet reflects versus absorbs. That's key to modeling its climate. We're not just learning about this one planet, we're learning how to learn about all the others. Because if we can do this for a gas giant, then rocky, Earth-like exoplanets aren't far behind. They're the next step, the holy grail, the ones that might show signs not just of chemistry, but of life. Imagine detecting ozone, oxygen, chlorophyll analogs, things that can't easily form without biology. That's the end game, and Webb just opened the door. And make no mistake, this is just the beginning. The telescope that made this possible sits nearly 1 million miles from Earth, locked into a gravitational sweet spot called the second Lagrange point. There, shielded from sunlight and Earthlight, it stares into the abyss with precision no other instrument can match. And the people behind it, thousands of scientists, engineers, programmers, and mission specialists across NASA, the European Space Agency, and the Canadian Space Agency. This is the product of global collaboration, decades of planning, and a shared hunger to know what's out there. And now we do. But let's go deeper, because what we're seeing in this exoplanet image is more than science. It's philosophy. It tells us that we are no longer alone in theory. We are, unmistakably, part of a galactic neighborhood. Planets are not rare, they're everywhere, and some, eventually, will look like home. Children growing up now won't have to imagine what planets beyond the solar system might look like. They'll be able to see them, study them, watch them shift and change across seasons. What used to be science fiction is now science curriculum. And the telescope responsible It's not just capturing data, it's reshaping how we teach astronomy, planetary physics, and spectroscopy. Real-world examples are now at our fingertips, examples that were just ink and theory a year ago. Webb's exoplanet imaging also plays a crucial role in mission planning for the future. Every parameter we extract from these images, albedo, atmospheric scattering, heat distribution, feeds directly into how we design new telescopes. Instruments like LOVOIR or the Habitable Worlds Observatory won't just benefit from this data, they'll be built on it. These new missions will have larger mirrors, sharper coronagraphs, and better star shades. They'll be able to block out stellar glare with even more precision. And that means smaller planets, potentially Earth-sized, are finally within reach for direct imaging. And what's more, Webb's data helps us calibrate Earth-based observatories, too. It bridges the gap between orbital observation and ground-based science, setting a universal baseline for exoplanet characteristics. But Webb's impact doesn't stop at imaging. It's also rewriting how we model planetary formation. Every storm Webb sees, every cloud layer it penetrates, every molecule it detects, this all informs our understanding of how planets evolve over time, how atmospheres grow, decay, get bombarded by solar wind, or cooled by distance. These are clues to planetary history, formation, and fate, and this knowledge, in turn, loops back into something much bigger: how life might arise elsewhere. We're beginning to link the chemistry of clouds, temperatures of stratospheres, and compositions of exoplanet cores to the story of biological potential. No longer are we just dreaming of distant worlds. We're diagnosing them planet by planet, system by system, and even beyond the science. There's a cultural ripple effect. This image is going to be printed in textbooks, shown in classrooms, displayed in museums. It's going to anchor documentaries, inspire art, and make headlines that reach people who never imagined themselves interested in astronomy. Why? Because it's tangible, it's real. We are now observers of other worlds, not just speculators. And in that moment when humanity first truly saw, an exoplanet, we crossed a threshold. We took another step outward, not just in distance, but in comprehension. Webb has shifted the language of astronomy from what if to what is. The planet in this image might not be habitable, it might not even be friendly, but it proves that the universe is not silent. It's filled with places. And now that we can see them, we'll never go back. Asterisk if you're as amazed by this discovery as we are, hit that like button, subscribe for more updates from the edge of the universe, and let us know in the comments what kind of planet do you hope Webb will find next. Asterisk the planet in this image might not be habitable, it might not even be friendly, but it proves that the universe is not silent. It's filled with places. And now that we can see them, we'll never go back. For most of human history, the stars were unknowable. They were distant lights in the sky points to navigate by, to mythologize, to worship. But now, we know that at least some of those stars are not alone. They host planets. And some of those planets might carry clouds, storms, auroras, oceans, even the potential for biology. And that idea that we're not staring at random dots of light, but at solar systems with real, physical geography is transformational. This isn't just astronomy, it's exploration. Visual confirmation of another planet isn't just a scientific novelty. It's a declaration that our technology has reached a point where we can chart alien worlds, not just with math, but with vision. The James Webb Space Telescope has cracked open a new window into cosmic cartography. It's giving us the power to not just imagine distant planets, but to understand them in detail. It's doing what the first telescopes did for Jupiter's moons or Saturn's rings, only now on an interstellar scale. Think about what it means to detect the colored bands of a planet's atmosphere from hundreds of light years away, to witness the dance of temperature variations across its cloud tops, to catch a pulse of auroral activity flickering faintly at its poles. That's no longer science fiction. That's data. That's science fact. And this data feeds a bigger ambition, one that extends far beyond the telescope itself. Because Webb's success isn't just in what it sees, it's in what it sets in motion. As more exoplanets are imaged and analyzed, we begin to build a new kind of database, a galactic census of planets with storms, atmospheres, molecular markers, maybe even signs of habitability. The bigger this catalog grows, the better we'll understand where Earth fits into the planetary spectrum. Is our world typical, rare, lucky? Webb helps us begin to answer, and for future generations, this new frontier becomes a foundation. It changes how we teach astronomy, how we frame the search for life, and how we prepare to explore beyond our solar system. Because once we can see something, we can plan for it, we can aim for it, and maybe, one day, we can go there. Think about how explorers once mapped Earth with crude instruments and risky voyages. Now we're doing the same on an interstellar scale, only this time the oceans are made of space, and the ships are made of photons and precision optics. But it also raises a question. If we can see them, can they see us? Every discovery like this makes us more visible to the universe. With every probe we launch, every radio wave we emit, every spectral fingerprint we leave behind, we add our own signature to the cosmos. We're not just observing anymore. We're participating, broadcasting, existing in a scale that might be noticed. And maybe that's part of all this image stirs in us. Not just what we found, but what it might mean. For centuries, we wondered if we were alone. This image doesn't answer that question directly, but it narrows the distance. It pushes the boundary, and that matters. Because even if we never find another planet with life, knowing that there are worlds out there, real worlds, with weather and atmosphere and movement, makes the universe feel less like an empty stage, and more like a vast, unfolding story we've only just begun to read. This is the legacy of Webb. It turns distant into reachable, theoretical into observable, and unknown into knowable. And now that the curtain has been pulled back, we won't stop. We'll look at more stars. We'll decode more atmospheres. We'll hunt for those elusive biosignatures, traces of oxygen, methane, maybe even chlorophyll. And when we find them, it won't feel like science fiction anymore. It'll feel like arrival at a new phase of understanding, a new kind of contact, not necessarily with alien civilizations, but with a deeper, richer view of the universe we live in, one where every distant planet is no longer just a guess, but a place. Asterisk, if you like this video, hit that like button and subscribe to the channel. For more stories that push the limits of what we know, drop a comment below. What do you think this means for humanity's future in space? Could we one day visit a world like this? Let's talk about it.